Hi, and welcome to my 3D tutorial using SketchUp and 3D printers. The way we're going to work today, I'm going to share my screen with you and show you how we use SketchUp to do 3D printing. So I'm going to switch to my program in 1 minute. And as you can see, I created some prep files in SketchUp. So our intention is to learn about design, learn about science, and units. Use 3D printers to use SketchUp to design the object and 3D printers to print it, and then we're going to test it. So before we start the lesson, I'm going to explain something about the catapults. Catapults are ancient mechanical tools, and they use a very simple principle. I'm going to show you the principle right now. You have a fulcrum, you have an arm, and you place the weight somewhere, and you use force to shoot the weight across space. So we're going to try to solve this problem using SketchUp and designing it. Since we're going to be working with 3D printers, I open a SketchUp file that's dedicated to 3D printing. It has this box, and this is the size of a 3D printing bed. And 3D printers work in millimeters, and as you can see, we work in the United States in inches, and it's really important to know which units are using. So in my case, I want to use millimeters, but I'm showing you the relationship between inches and millimeters so you can think about it when you're working. So this is my space. This is the maximum size object I can make in this project. The challenge with 3D printers, it takes a long time to print large objects, and since we have limited class time, your design cannot take more than an hour to print. I will have to print it in your recess, but at least you'll have it ready. So let's look at the process. So the first thing, I have the dimensions in my mind. So I'm going to draw a box that's 3 inches, comma, I make sure I write the units, because without the right units, we cannot solve it. So this is the size of my workspace. And as you can see, the way I designed this, this is not a SketchUp tutorial. You've had enough training on that in previous videos. But I thought if I made it 2 L-shaped brackets, have an arm, and my arm can hinge around the center point, then I can make a catapult that can make a part that moves, and I can put a rubber band from this end to that end, and that will help apply force to this fulcrum, and I'll be able to move my catapult and throw my object across the room. Our catapult is going to be very small, but still be very effective. So to do the design, we can, like before, draw any shape we want. So this is my L shape, and give it thickness. I can carve the extra material I don't want by just drawing lines and pushing it away. For the purpose of this exercise, I was very careful not to waste material. So I made everything as thin as possible. So this big L-shaped piece that I made right now is going to waste a lot of plastic. So I'm going to offset this side like this and make it mostly hollow, because I don't need that much material on the inside. So I'm going to make it this hollow, and that way it will still be strong enough, but I'm not wasting material. So I'm thinking about my responsibility towards the environment. There's no point of wasting plastic when I can make it with a very minimum amount. So all my pieces, as you can see, the basket where the object will be thrown is mostly hollow. This channel is hollow. These pieces are hollow. This piece is very thin. And I designed it where I made sure that I did cut holes here, and I added the same size hole pieces of plastic a little bit thinner. So when I glue these together, this will snap in place. And I made this axis, I made it wide enough so the piece can loosely, my arm can loosely swivel without being obstructed. So I have to think about what I'm designing, measure it, test it before I actually build it. So now I take my objects that I made here, and I want to make sure they're ready to print, but they cannot print if they are in 3D, standing on their edge. 3D print is still built from the floor up. So I took my objects, let's say we can take this side, I'm going to copy it, I'm gonna place it there, and I need to rotate it. So it will sit flat on my printing bed. So I'm gonna put it there, rotate it 9 degrees. I already made one before, so I'm gonna delete this one and this one. Because to make my catapult, I designed it where I need only 3 pieces. I need one side, 2 sides, a middle piece, and that middle piece. Notice that this piece and that piece are basically symmetrical. They're the same exact object copied twice. So now I'm ready to print. So the next step, after my objects are the right size, the right design, they're placed on the printing bed on this space, I go to File, Export STL, and see how it's in millimeters. I can export my file, and I'm going to call it a side class catapult. So by just clicking this, I just save my file that's ready to print. So now, the file is going to go from this space, convert it as STL, and go to the actual 3D printer. The way 3D printers work, they have Y-axis, X-axis, and Z-axis. Later on, I'm going to show you the video of the printer actually working. But this is the extruder head, and the extruder head melts plastic and puts it there and coil it. It goes left and right till it finishes one layer. Then it goes up and starts building the next layer. And most 3D printers that are commercially available work like this. So we're going to use same technology, and we're going to start printing, and we're going to see if this miniature catapult can actually work.
I'm gonna test the mini catapult.